So, hi everyone. So, today we are back with another video. In this video, we'll be going through a real interview problem for a company like Amazon. And we have Parik with us. So, let's see and stay till the end of the video to see if Parik is able to solve the coding problem that I gave you. So, let's get to it. Before that, let me give you a brief introduction about me. I am Varun. I recently graduated from University of Wisconsin with my master's in computer science. I was previously studying in NSIT and I've got a chance to work in companies like Expedia and Microsoft. Parik, would you like to tell us something about yourself?
So, hi everyone, myself Parik here. I currently work at Coding Ninjas and have experience of working at Amazon. So, today I will be facing a real interview problem after so long. So, excited to do that.
Okay, cool. So, let's jump on to the problem. Okay, Parik?
Right.
So, hi Parik. So, today we'll be having an interview. Let me give you a brief format about the interview. So, the interview will begin with a brief introduction about yourself. I would like to know what you have done and what your past experience is, and then we'll jump on to a coding problem. We'll share our screen and I'll give you a problem and we'll have a live code pair session.
Sure.
Okay. So let's start with a brief introduction about you.
So, myself Parik, and I've graduated from DTU, and from the last 3 to 4 years, I've been working with Coding Ninjas as one of the software developer and founding members. It has been a great journey so far. I have worked on a lot of projects. We have a platform named CodeZen on which students make a lot of submissions in different languages. I myself have worked on different languages like Python, Java, Ruby on Rails, and worked as a web developer as well. So I have overall much experience with me in terms of development and teaching as well. So I'm one of the instructors of Python and competitive farming in the Coding Ninjas. So that's a brief introduction about me.
Okay. Cool. That seems interesting.
Right.
Let's jump to the coding problem. So can you share your screen with me? Yeah. So you have heard about binary search trees, right?
Right.
You know the property. Can you tell me the property of a binary search tree?
So binary search tree is that I assume that there is a binary tree. I can assume.
Yeah.
So there is a binary tree in which for every node, the nodes in the left part are smaller than that node and nodes in the right part are greater than that node. I'm assuming the duplicate elements are not there. So for that, we can consider that one is the right one.
Okay. So jumping to the problem. So let's say you have a binary search tree like this. Okay. So in this tree, 8 is the root node, the left child is 5 and the right child is 9. For 5, the left child is 1 and the right child is 6. Okay.
Sure.
And for 9, there is only a right child, which is 10.
Sure.
Okay. So now what I want is that I will give you two nodes, say for example 6 and 10, and you need to tell me which is the first ancestor going from bottom to up that is common between the path from root node to this node.
Okay.
You understand the problem? Let me give you an example. Okay. So for example, if I give you 1 and 6. Right. So the first node going up from both of them is 5 and it is common to both of them. So this is what I'm looking for. If you take the example of 6 and 10, the first ancestor going up from 10 is 9. The first ancestor going up from 6 is 5. They are not the same. So let's go one step up. So for 5, it goes to 8 and 9 also goes to 8. So now this is the node which came first from bottom up and this is the ancestor that I'm interested in. Is the problem clear?
Right. So 2 to 3 things. One thing I want to ask that you are asking about 2 nodes, right?
Yeah.
Always 2 nodes. Okay. So 2 nodes and they are present in BST always?
For simplicity, let's assume that they are present in the BST right now.
They are present in the BST and it's a BST. Just for simplicity, it's a BST.
Yeah.
Okay. And I need to find out the for 5 and 10 the answer will be 8, right? They
Yes.
don't need to be in the same level, right? That's what.
No. Yeah.
Perfect.
Yeah.
So, should I? What is the next thing?
Like, yeah, go ahead, try to solve it. Think about it, how
Okay.
you'll solve it. Let's
Okay.
walk through a solution before like
So
jumping to coding or
let
anything.
me just define a function. I think a kind of function which I need to implement, and then I will give you the thought process
Okay.
so that I have a better
Okay.
clarity.
Okay.
So I can assume
Yeah.
a node is there. This is a binary tree node kind of thing, and
Yeah.
whatever is the binary tree node have, what they have is data, and they
Yeah.
have a right and they have a left, right?
Yeah.
Sure. I'm assuming this is small. Okay. So we have a node, and I think the function which I need to return is I need to return the node or the data.
Anything. Let's go with the node.
Okay.
Let's
So I need
return
to
the node.
return the node. I
Which
think
is
we
like,
can say first common ancestor, right? I can say like this,
okay.
right?
Yeah.
And you will be giving me root of the tree.
Yeah.
Sure. And you will be giving data of two nodes or the nodes.
Let's say that I give you the data of the two nodes.
So let's say there's node 1 data and we have a node 2.
Yeah.
And I need to return the function this. So I will be writing in Java because I'm comfortable in this. That's okay.
Okay. Yeah, that's perfectly fine.
Sure. I think that's a function. So now let me give you an approach through which I can solve this. So I have two nodes. Let's assume 6 and 10. So 6, if I'm standing at 8, since it's a BSD, 6 and 10, I know 6 will be in the left and I know 10 will be in the right because 8 is greater than 6 and 8 is greater than 6 and 10 is greater than 8. So that means 8 is smaller than 10. So one is in the left part and one is in the right part. Can any node in the left part further be the ancestor? No, because 10 cannot reach there. And can any node in the right part be the ancestor? No, because for 6 nobody can be there. So I will be the first common ancestor because one is in the left part and one is in the right part. So definitely I will. So
I didn't get it.
What I am saying here is if I am standing at 8, right?
Okay.
I know and I need to calculate the ancestor of first common ancestor of 6 and 10, right?
Yeah.
So since 6 is present in the left part because I know 8 is greater than 6, so I know 6 in the left part. And since 10 is greater than 8, I know 10 will be in the right part, right?
Okay.
So since I am standing here, now any node if you consider in the left part, whether 5 or 1, they can never be the ancestor of 6 and 10. Because from 10 you cannot reach ever 5. Similarly, from 10 you can never reach 1.
Okay.
Right?
For this tree.
Similarly, in the right part, I think from 6 you can never reach 9.
Okay.
Because if I'm standing at 8, one is in the left part, one is in the right part. Now I will be the ancestor because any further downwards, nobody can be an ancestor because from either of them you cannot reach the nodes. Right? From 6,
how can you be so sure about that?
Because from 6, if you move from 6, you will move on to 5.
Okay.
And from 5, you will move on to 8.
Yeah.
Then from 8, you will move on to further. Always you cannot go to the 9, right?
Okay.
And similarly, from 10, you will go to 9. Then from 9, you will go to 8. You can never go to 5 and 1.
Okay.
Right? So since both one is in the left part, one is in the right part. So I can definitely say I myself will be the lowest common. I myself will be the first common ancestor. Right?
Okay.
So similarly, if I follow for 1 and 6, what I will do is for 8.
Yeah. Yeah.
So since I know both the nodes are in the left part, 1 is in the left part, 5 is in the left part.
How are you sure that both the nodes are in the left part?
Because 1 is smaller than 8 and 5 is smaller than 8.
1 and 5? Aren't we looking for 1 and 6?
Sorry, 1 is smaller than 8 and 6 is smaller than 8. Right?
Okay.
So GST property follows that since the nodes are smaller, comes in the left part.
Okay.
So 1 and 6.
Okay.
Okay. So their first common ancestor can definitely lie in the left part.
Okay.
Because their lowest common ancestor can never occur in the right part. I can be sure. Right?
Okay.
Because from 1 and 6 you can never reach 9 and 10.
Okay.
Right? The only thing I can be the common ancestor now, it will be if one of them I will, like if I am calculating for 1 and 8. Right?
Yeah.
I myself is one of the node.
Yeah.
And one node is in the either in the right part or in the left part. I can say I will be the first common ancestor. Because one is in the left
Yes.
part, obviously from that I will reach here. Because nobody can reach, I can say that if myself is standing here, and since
Yeah.
the other node is in the bottom, obviously
Yeah.
this is the least part I can be the ancestor.
Okay.
Right?
Okay.
So,
Can
and
we
if-
just stick to the Can we just stick to the example of 1 and 6 and see
Ah.
how you will walk through your
Sure.
solution?
So for 8, since 1 and 6
Yeah.
are both smaller, so I will
Yeah.
go to the left node. I will skip the right part whole, and I will go to.
Okay.
Now again,
Okay.
I'm standing at 5. Since 1 is smaller than 5 and 6 is greater than 5, then I know this is my edge. And I will just return from here. I will never go further downwards. As soon
Okay.
as I reach
Okay.
a node where one node is on the left part and one node is on the right part, I will just
Yeah.
return from there. I will
Yeah.
not go anywhere. If
Okay.
both the nodes are in the left part, anywhere, if both the nodes are in
Yeah.
the left part, then I will go to the left part.
Okay.
And similar strategy, like for like 9's left is not there, but somehow if 7 would have 8.5, let's say
Y-
8.5 would
Okay.
have been there. Then for 8.5 and
Yeah.
10, I would have gone to 9. Standing at
Okay.
8, since 8.5 is greater than 8 and 10 is greater than 8, obviously I will go to the right part.
Yeah.
I will totally skip the left part.
Okay.
Right? And this is how I can calculate the LCA, because I have approach for everything. If both the nodes are in the left part, I will go to the left part. If both the nodes are in the right part, I will go to the right part. If one is in the left part and one is in the right part, then I will be the ancestor. Right?
Okay. Okay.
Or one is in the left part or in the right part, or if I am one of the nodes, then I will be the ancestor. Right?
Okay. Okay.
Sure.
That seems like a reasonable solution. Let's jump on to the coding part of it, and then let's do a dry run after you complete the code.
Sure. So let me just do one thing. Okay. So I think let's solve the left and right part first. So if I assume that, not assume, if root.data, I am telling it's strictly greater, is greater than n1 data, and
Yeah.
this node 1 data, and root.data is greater than n2 data.
Okay.
If I have written this, that means I can surely say that my data is greater than both the nodes data.
Yeah.
That means both the nodes are in the left part.
Okay.
Right? So I will say that, hey, I will call this recursively. Whatever is the answer of this, I will call the left part. I will pass the same n1 data and n2 data. Whatever lowest common ancestor or first common ancestor it will return, that will be my answer.
Okay.
Okay. And similarly, the similar condition is like this. Else if root.data is greater than n1 data and root.data is greater than n2 data, that means, if I have written this, that means both the nodes are in the right part. Now whatever the answer will be there, the right part will return me. So I will just, let me just copy this. So I will just call the right part and it will return one data and two data. I think this looks fine. Both in the
Okay.
now. Okay, one thing I can always do is that if root.data is n1 data or root.data is n2 data, either of them, then obviously I will be the answer. I don't need to go further downwards. So I will just return root from here.
Okay.
Now the thing is
Okay.
remaining is now if one of them is in the left part and one is in the right part.
Yeah.
Okay. One is in the left part and one is in the right part. So I will come to the situation here. If neither of them satisfies, that eventually means like both the nodes are not in the left part both the nodes are not in the right part, that means one of them in the left part and one of them will be in the right part. And that eventually means I will be the answer. So I can just return root from here. Right? I don't need to go do anything. And the thing remaining is I can write the base case. If root eventually reaches out to null, since both the nodes are in the you have said that both the nodes are in the BST, so I think I will be able to find out the LCA. But for some edge case, if you ask me, then I'm just writing the base case, so it will be returned.
Okay.
So is that cool?
Let's walk through an example. Say for example 6 and 9.
6 and 9, sure. So 6 and 9, I have called for the root. N1 data is 6 and N2 data is 9, right?
Yeah.
I have presented 8. Root is not null.
Yeah.
Okay? And root dot data is not equal to N1 data, and root dot data is neither equal to N2 data. Because 8 is not equal to 6 and 8 is not equal to 9, right?
Yeah.
Then I will go to this code. This will be if root dot data is greater than N1 data. So 8 is greater than 6.
Okay.
And then root dot data is greater than N2 data. No, 8 is not greater than 9. So I will skip this part.
Okay.
Okay. Then I'll say root dot data is lesser than N1 data. 8 is not smaller than 6. So I will just skip this part. And I will just return root from there. So I will return 8. And I think answer for 6 and 9 is 8.
Yeah.
Yes.
Okay. And what about the case when it's 5 and 6?
5 and 6, sure. 5 and 6 will be like I am present at 8, right?
Yeah.
So since 5 and 6 will come here, root is not null. Root is not equal to N1 data and root is not equal to N2 data because 8 is not equal to 5 and 8 is not equal to 6.
Yeah.
I will check this condition. If root dot data is greater than N1 data, 8 is greater than 5, sure.
Yeah.
And 8 is greater than 6, sure. So I will go to this condition. I will say take all the first common ancestor, and for the root dot left part, I will go to this 5, and N1 data and N2 data will both be 5 and 6 only.
Okay.
So I have come to 5. Root is not null, sure.
Yeah.
Root dot data is equal to N1 data. Yes, 5 is equal to 5.
Yeah.
So I will just return root, and next condition will not run because this has been satisfied. So return root. So I will return 5 from there, and I think 5 is the answer.
Okay. Okay.
For new programming updates and videos, subscribe to Coding Ninjas channel.
What do you think will be the complexity of your solution?
Complexity. So if you know about balanced kind of thing, it's a balanced BST or not?
Let's say, how does that make a difference?
So it makes a difference kind of thing. Like this. If I have a skewed BST kind of thing, 8, 9, and 10, 11, kind of this thing.
Yeah.
Let's say this 12. Okay, at this case.
Yeah.
So if I am calculating the first common ancestor for 11 and 12, right? So for this, I will be traversing on every of the node, almost every of the nodes, right?
Okay.
It's kind of n minus 1 nodes if I have total n nodes.
Yeah.
So the complexity can be n minus 1 there, so order of n there, right?
Okay.
But if it is a kind of a balanced BST,
okay.
So the worst case complexity. So in case of balanced BST, right? So the thing is, if I am one of the common ancestor, I just return from there, right?
Okay.
But if I am not the ancestor, I only go on to the one part, either in the left part or in the right part.
Okay.
Right. So for every level, I am traversing only one node.
Okay.
For every level, I am traversing only one node. So I am just in terms of height, if I am traversing whatever is the height of the tree, that can be the worst case. So in that case, the height in case of balanced BST, it can be log n, kind of.
Okay. Okay. So if instead of n, if we talk in terms of h,
right?
Like
so
the height.
it will be order of height. It will be order.
Okay. Yeah, that makes sense. Okay. Yeah. Chal. So Eric, I think this will work. So I had a counter question to this. So instead of giving you 2 data points, what if I give you an array of integers and I want you to find the common ancestor of all those integers? Like, let's not think about the code right now. What I want you to do is think of the solution, and if time permits, we'll try to write a code for it. But I'm more interested in the solution.
So you said about array of integers. You are giving array of integers. So again, it's a BST, right?
Yeah.
Second, can I assume all the nodes, all the integers are present in the BST?
Yeah. Don't change any underlying assumption.
Okay. So you are giving an array, and those nodes are present in the BST.
Yeah.
So okay. So since they all nodes are present in the BST, what I can do is I already know how to calculate LC of 2 nodes.
Yeah.
So okay. Just give me so if both the nodes. So I can do a calculating pairwise LCA kind of thing. Okay. What it will do is, like, we are given an array of nodes. So first I will find out the LC of first 2 nodes.
Yeah.
I will get some, let's say, A. I will calculate LC of this A and with the next node, with the next element of the array. Then I will get some B. Then I will calculate the LC of this B with the next element in the array. And keep doing that till I reach the last element of the array. And once I reach the last element of the array, I will have the final LC. And since they all nodes are present in the array, so I will have some LC, right?
Okay. So yeah, that's one approach. What will be the time complexity of the solution?
Time complexity. Calculating LC of 2 nodes is order of 5. So what is the size of the array?
Like, it can be at max the size of the number of nodes in the tree. So n.
So n. So it will be n into height. N is traversing in the array, and order of height is calculating LC of 2 nodes. So it will be order of n into order of height. That means order of n into height.
Okay. So yeah, that's one approach, and I think that will work. Can you think of like optimizing this approach? Can we use some property of a BST to like optimize this? Is it possible to optimize this? And if yes, how?
Elements or whatever you have given me the array elements. I'm finding out one by one. So I need to calculate also. I'm calculating currently, and that is taking the time. I have HCF 2 nodes. So if one is there, can I optimize into HCF 2 nodes?
Can you think out loud? You can think out loud.
So what I was asking is that do I literally need to calculate LCA of every pairs, or we can like that? So if one element is present the leftmost, rightmost, LCA. So I think it, one can be there that if I have array elements, right?
Yeah.
I think they will be unique.
Yeah.
Right? So if they will be unique, so I can calculate the minimum and maximum out of them. And the intuition says is that I just need to calculate LC of them. I need to just calculate the LC of the minimum and the maximum element present in that. And that will eventually give me the LC of whole elements. Because rest of the elements will eventually fall into that range kind of thing, right? Because if minimum is there, maximum is here, they will fall into this range, definitely.
Okay.
So intuition says that minimum is here, maximum is here, LCA somehow kind of lies here. So the rest of the nodes in the array will lie in between.
Okay. So how did this improve the time complexity? What will be the time complexity?
Because now what I need to do is calculating minimum and maximum will take order of n time, right?
Okay.
And calculating LCA of 2 nodes is again order of height. So it will be n plus h. Whatever is, I think n is there. So order of n kind of thing.
Okay. So we improved from order nh to order n plus h, which is like order n.
Kind of order.
Okay. Okay, cool. Yeah, I think this will work. So thanks, Parik, for taking out the time to interview. We'll get back to you with the next steps. And till then, best of luck. So welcome back, guys. So luckily, Parik was able to solve the coding problem that I gave him, and he was even able to answer like the cross questions that I had. So good job, Parik.
Thanks, Varun. Had a great
So
time.
yeah, so see you guys in the next video. Let's see if you learn from the next video as well. So
Sure.
thank you.
Thank you, guys. Bye-bye.
Bye.
For new programming updates and videos, subscribe to Coding Ninjas channel.